All right, in this exercise we're going to do today is learn how to make a spaceship fly. And not only does it fly, it's also going to scroll across the screen. So there's a few things that make this work, and the first thing we need to talk about is the geometry and some quite simple math that actually makes this work. So let's take a look at an example of this on this graphic program I'm going to use to demonstrate this with. So the things we need to know first off is if we build our game at 14 grids by 14 grids, we know how big that is in pixels because each grid square is 32 pixels wide. So when I add the math up on this, I essentially have 14 by 14 on the pixels and on the grids, multiply each grid square by 32 pixels, and I get 448. So the game is 448 pixels by 448 pixels. Why do we care about that? Well, we care about that because we need to know the coordinates of the game in order to think through the math of how we're going to get the object to move and reset its position every time it leaves the boundaries. So for a moment, consider this. The idea that we're working with here that's kind of confusing initially for a lot of people is that we're typically dealing with, we're used to dealing with a coordinate grid where each quadrant of the grid, quadrant 1 is negative x, positive y, quadrant 2, maybe this is quadrant 1, I can't remember how to count these, but this top right coordinate grid has plus plus for x, y, then this one is positive x, negative y, and this one's negative y, negative x. So each coordinate with the origin is 0, 0, is what makes that work. Then we know that what's weird about systems like Adobe Flash, Adobe Animate, a few other systems that we use in motion graphics, they use this bottom coordinate down here. So it's positive. It's sort of a positive x's, but the y's get bigger as they go down. So it's really not negative numbers. It just gets bigger as it goes down. So if we think about this and sort of observe our system, then our grid looks like this. The top left corner is 0, 0, top right is 448, 0, bottom is 448, 448, and bottom left is 0. So our x-axis and y-axis are 0 at the top left-hand side. Knowing that to be true, we can then determine that where our ship is can have some certain value. So when we know that when the ship leaves this area, for example, if the x gets greater than 448, then we need to reset the x for the ship back to 0. So the same with the y. If the y goes below 0, we should reset it back to 448 so it flies across the screen. So consider that as we look at the ship flying, that here it's going to go below 0 on the y and it pops back up to above 0 or just below 448 on the y going this way. So how does this work? Let's take a look at the system that makes this happen. So if we have our ship, which I've provided a graphic for you on this today, we need to make sure that the physics have this set to movable. And I do have a glitch happening today where it's not actually going to be movable. So we're going to use a couple things. We're going to use ship controls and edge scroll. So there's two different things we have to make, and let's talk about the ship controls first. So the ship controls uses 3 triggers, and the triggers are up here, of course. We're going to use the keyboard trigger. So just click keyboard 3 times. And what I'm going to do is I'm going to demonstrate building this, even though I've got the example right there. So I'm going to cancel this, and I'm going to go, let's get 3 triggers, 1, 2, 3. So I clicked it 3 times. I might have done 4. I'm not all the way certain. There it is, just 3. So the top 2 are going to be left and right. So click change key, hit the left arrow, or ASDW, whatever you want to use. It's fine. And then I'm going to hit this one, and I'm going to change this one to the right arrow. Okay, so right arrow is this one. This one here is going to be our up arrow. And the only purpose of the up arrow is to project the object. Now I got to check something here, and these should be repeating. So repeating means if you hold it down, it keeps working. If you don't click repeating, it just works once when you hold it down, when you hit it the first time. So you'd have to keep clicking it. So with this, you could, there we go. So with repeating, it means that the holding key down is going to continue to engage the process. So it's sort of a different operation on how it recognizes the key action. The next thing we want to do is use our rotations. So the object properties, and we're going to go to rotation. We need 2 rotations. So we're going to use rotate left and rotate right. And actually what I need between those, oops, sorry, let's delete one of these. I've got this completely backwards. You're going to use a number. So you have to feed it a number. And this is the speed of rotation. So I'm going to use, for the left, I'm going to use -4. So we're going to steer left here in the label. Now the label is not essential. It will work without it, but it makes more sense for you, the programmer, if you make these notes in there. So steer left, and steer right. So this number here needs to be 4, so they're essentially rotating in 2 different directions. So once we press down on this, we're going to use the get. Get used to be called in, and now it's called get. And then we're going to use set. Nope, sorry, add. So we're changing the rotation of the object. So if we look at that, I'm going to go ahead and delete my original piece here. So there is a new tool in here. If I can grab this and delete those pieces, I can actually just cut them out. So if we test this, we'll be able to see that it rotates. And if we look at what's happening here, let's get back in there, sorry. So ship controls, open bundle. Okay, so I wanted to see what this is happening with. So as I rotate this around, you can see the numbers transferring. Now if you hit both of them at the same time, it still feeds it, it just doesn't move. So you can rotate around as you see fit. Now the part with the up is going to engage a number. I think it's got my example down there. So we engage a number and we use the number 6, and we're going to introduce a new 4, 5, or 6 is fine. And we're going to go to the getter, and we're going to use a thing called a motor. Now the motor, I believe, is a component. It's in here somewhere. Impulse motor, there we go. So what the motor does, it acts like gravity. It changes, instead of setting the speed at an automatic, it increases the speed gradually over time. So let's watch how that works. Now I'm going to go ahead and delete my old one. I think I got this right. Cut, there we go. So what I can now do is try this out and run it. All right, so that part's pretty easy, but keeping it on the screen won't work for you just yet. So I'm going to go here. Now what you can do is there's 2 ways of making that into a bundle. And the benefit to making it into a bundle is if you have a bundle of this and you click add to menu, you'll then have it in your list of behavior bundles. So you can use these across multiple games while you've only programmed it once. So what I encourage you to do today is make your ship controls as a bundle, and then you can click add to menu, and it's going to add it into the menu. I think I've already got one over here like this. There it is, ship controls. And so I'm not going to add it in there, but the edge scrolling, I don't like my edge scrolling that I'm having here, so I'm going to take this. So if I have a bundle I want to get rid of, I can click and hold, and pretty soon this wheel shows up, and I'm going to delete this one, and edge scroll this one is also going to go away because I made a better one. So now we're going to engage the piece that allows it to fly across the screen and scroll. So you can make the bundle first by doing a new bundle, or what I'm going to show you how to do is add something to a bundle once it's already made, and that allows you to take objects on your screen and clean things up a lot more than we used to. So this is some new stuff that they've added to Flowlab in the last week or two. Really exciting stuff, and let's see what we can do. So the first thing we need to have is we need to have a trigger, and we're going to use the always, which means this will happen constantly, frame by frame. What this actually is based on the frame rate of the game, which is about 30 frames per second. It'll do this 30 times per second. So it says always, but if it was always, it'd be really constant instead of 30 times a second, which from our perspective in time seems like all the time, but it's actually, there's some gaps in there. So what we're going to do is we're going to use a property, and we're going to extract the properties. So we need 2 extractors. So I click twice, and one is for the X, one is for the Y. I'll leave the X up here, this X, and this Y. So this is attached to the little ship object I've made, and we're going to make this into the Y. So what this does, it says, where are you, right? Where are we in the X and the Y? So it determines the XY position. And as you may recall, XY position is really important in this process because it needs to know where is it to determine if it's time to reset the position. So the end result of this will be a position value. So we're going to get 2 positions. One is X, one is Y. And we're going to use this to determine the position of the object. So what we're going to use is, once we get that value, we want to use something that determines does it meet certain criteria. So we're going to use a logic and math piece called a filter. And the filter, we need 4 filters. So I'm going to get 3 more. Oops, not expression. Sorry about that. Delete and filter. 1, 2, 3. So I need a total of 4 filters to determine the position if the position meets certain criteria. So again, visually speaking, we're trying to find out Is it less than 0 on the x? Is it less than 0 on the y? Is it greater than x, greater than 448 on the x? Is it greater than 448 on the y? Now, if your game is a different size, then you're going to want to determine, based on the grid size, multiply by 32 to determine what those pixels should be. So there's a little bit of math that's not always going to be 448. So popping back into here, we want to find out, is this, in my case, is it less than 0? So I need to change this to less than. And 0 is going to work there. This one's got to be greater than 448. And this is the same thing. Less than 0, greater than 448. Oops. So now I got that. So once I've got that in place, next I need to engage some numbers. And the numbers are going to be opposite. We're going to do 3, 4 of these. And we're going to run the same numbers. And in fact, let's try something out. If I select these two objects using this little selector here, this box selector, I'm going to cut these out. What I want to do is take these two. So if it's less than 0, we're going to reset it to 448. Now, going back in here, just to remind you of the math, if we get less than 0, it's going to reset it to 448 to move it from the other side. So that's all we're doing, is just resetting its position. So if I got 448 and 0, this one's going to be 0. Let's try something to see if this works. I haven't done this before. So I'm going to select both these objects. I'm going to select both those objects. Let's see, I've got the thing. And I should be able to select multiples of them. I'm not sure why it's not working. Let's see. Grab the thing. Oh, it's working as it goes over. That's interesting. So let's just see if we can select multiples of this. Nope. So if I go over here, there we go. So I got that. I'm going to copy this and paste. So by some bizarre theory, it would appear that I was able to copy and paste them. So you can do that between functions as well, I think. So what I want to do is, if it's, again, the filter is less than 0, it's going to go to 448. If it's greater than 440, it's going to go to 0. So we're going to connect all this. And if we just do this part first, we can actually see the number it creates. So, well, the 1 is going in, and it means it's working. So if I run those and connect those to these filters, we should be able to see the number of passes. So it's passing 80. So its position is 80. And as it moves, you can see those numbers changing. Okay? So what I got to do on this one also is connect it to the end. And it's always important to test as you go by running those numbers to see what they're doing. So we've already built more than we should have in terms of testing, but we're just building up the system to help you out and understand the math. So we're going to pass this number. If it is true, then we're going to get that value. So we're going to run the getters to there, pass to the getters. So again, if it's less than 0, we set it to 448. If it's greater than 448, we set it to 0, and the same thing down here. Then we can run this to the x here and here, and I think that'll work. My original version actually has a separate positioner for each output, but I think it works well like this. So it cleans it up a little bit more. So if I move it up, you're going to see the synapses pop and change. So it works that way. And now it's going to go this way. And that also appears to work. So that's the whole deal for this. And later we'll learn how to add shots to this, which is actually quite simple. But that's how you build up a spaceship flyer. Not a bad idea to get in here and change the space color to here. And what I can also show you later on is how to build a self-generating star field so that we have stars that fly by to add to the effect. So for now, that works good, works well, if you will, and you're going to build one of these up and turn it in today. All right, have fun with that.